Hello, my name is Kevin Pearies. I'm a Senior Applications Engineer with Exfo. So today I am using the FTB1 platform with the FTB880 module, but a lot of the interface and setup that I'm doing with this particular solution will be relevant on some of our other Ethernet test modules as well. So if you have the newer software load for the FTB800 series Ethernet testers or any of the FTB88100 Ethernet testers, the interface should be very, very similar. So a lot of the things we're going over today will be relevant for those solutions as well. Obviously, there might be some different options as far as rates that we see in some of the drop-downs, but to a large degree, it will be the same. So I've already launched the module, and I'm in the test application screen right now. So as you can see, this particular version that I have has a lot of different test options. So we'll be working on EtherSAM Y.1564, which I already have selected. So once it's already selected and loaded up, we'll go ahead and go to the test configurator to set up the test. So this screen right here in the test configurator is kind of our home screen for Ethernet setup. And so how it works is from the left to the right is kind of how we flow. So we'll start on the left and work our way over across the windows towards the right and then set them each up individually. So one of the first things that you want to do is set up your rate and get link with your network. And so down here in the bottom left we can see that we are set for port 1 GigE right now, but we don't have link. And the reason for that is because this particular test that I'm doing is an electrical test. In fact, on the far end, I have a FTB 88100 NGE. So this is a screenshot I took of that device. And it is sitting in a smart loopback capacity. So it is doing basically just a smart loop. It is swapping source and destination. I have it set for IP mode, so we can have it set for Ethernet mode, to do MAC swapping. In this particular situation, it's doing IP swapping. And the IP address of this particular device, so the destination IP address we are working with today is 10.10.10.2. So that's one of the important things to understand is it's really critically important to make sure that you have all of the information that you need before you get in there and do your testing. And one of those pieces of information is the destination IP address if your network is IP aware. So I'm going to go ahead and go back to our test set here. And so we need to set this up for electrical testing. So up here in the top right, I will select Modify Structure. And then from here, I'll get a pop-up window where I can select the different interface rate options. So right now, here is what I have enabled on this particular solution. And so I'm going to go ahead and select 10, 100, 1000 electrical. And we will have two connector or port choices here, port 1 or port 2. Most testing that we do is on port 1, so I'm going to go ahead and select port 1 and hit OK. And so basically the test set now will modify the structure. It will disable the GigE SFP that was enabled and then configure it over to the 10, 100, 1000 electrical interface. And so we've done that here. And as you can see, we got a link already. So we just happened to be set up because I was doing some initial troubleshooting earlier to make sure that this went smoothly. So I cheated a little bit and we already have a link. So if you look here on the left, it's set for port 1 RJ45. And so this very first window here, we have the transmit and receive is coupled. And so our very first window is our port interface setup. So I'm going to go ahead and hit this little magnifying glass on the quarter to expand it. So if we were to, say, change the speed on this particular test, we'll lose link. And so we'll assume that we started at this state where we did not have link. And so one of the first things you need to do is establish link with your network. And so if you have auto negotiate turned on within your network, then you can turn on auto negotiate and then we will negotiate with the port for the rate, the speeds, and the flow control and all that good stuff. In this case here, auto negotiate is not going to help us because I'm just testing to a smart loopback device. There is no auto negotiate device in play that we can negotiate with. And so I'm just going to go ahead and go in here and set it for 100 megs. So I would manually set it up. And then once I do that, I have link. So now I have link with the port. We can go in there and set up the network. And so the network will be the actual test port itself on the FTB880 here. I need to give it a MAC address and an IP address in this case. Now certainly if you don't have an address aware system, so if there's no routers and switches in play, if it's a transparent network, this information is not really relevant. In this case here, we're going to step through it just so we know how to set it up. So if there's any sort of MAC swapping device, if there are any switches and routers in play, you will need to know what the MAC and an IP address that you need to set up to be able to negotiate and communicate and test across that network. So in this particular screen here, we're setting up the test port on the actual test set itself. So right now I'm going to leave it for the factory default MAC address here. You can disable this and manually put in a MAC address if you so choose, but in this case we're going to use factory default because that will be unique to this particular device. So we're not going to have any sort of MAC address conflict possibilities if we stick with factory default. For the IP, this particular unit we have it set up for .146. And then the subnet mask is 255.255.255.0. If there's any sort of VLAN tagging, we do support Q&Q, so we can tag a VLAN if we so need to. In this case here, I'm not gonna do that, so I'll go ahead and disable it. So here's our MAC address, and here's the IP address of our test set. So we can go ahead and close this down. So now we're finished with this particular window. We have a link, so we can move on. So we want to make sure we have this. Now, obviously, you need to be plugged into a network or some device that will give you a link. If you're just setting this up standalone, you can put a loopback device on port 1 to kind of get linked just to verify the configuration. So in this case, we have a link. We are happy. So now we'll move over to the next window, which is the services section. So I'm going to go ahead and expand that window out. And so here is where we can configure our individual services. So EtherSAM allows you to test up to 10 different services. And so each one of these services can have different frame sizes. They can have different destination MAC and IP addresses. So there's a lot of different configurations that you can set up here. And so just for the sake of time, I went in here and created 8 services using different frame sizes. So they're all fixed. I actually used the 7 recommended frame sizes from RFC 2544. And then I added an 8th that was a jumbo frame at 2,000 bytes. And so basically how I set this up was, from default, it would normally be disabled. So in this case here, we're just going to set up this one service. So what I normally do is I will get in here and name the service first of all. And the default name for the service that we have when it ships is service 1. So this is what the service name is. I like to name it something that's more recognizable to me. So I name this one 64 because I'm setting this particular service for fixed frame size 64 bytes. So that's what I go ahead and do. I name it. And so you can tell which service we're on here by what's highlighted. So we're on service number 1 right now. If I were to go to the right, we go to service number 2. So I'm going to stick with service number 1. The information rate, you can either set it for relative or absolute units. And so in this particular case, I have it set for megabits. Remember, this is a 100 meg circuit, so I want to do 8 frame sizes. So I'm taking 8 and dividing it, dividing the bandwidth across 8 services. So I'm expecting about 12.5 megs per service. And so this very first option here, committed information rate, is just that. Committed information rate is basically your SLA or your contractual speed for the customer. And of course here, I need to set it up for 1/8 of the total bandwidth because we are separating this again across 8 different services. And so in this case here, committed information rate is 12.5. Now, if you were going to test EIR, which is extended information rate, so CIR, committed information rate, is basically your contractual bandwidth for the customer. EIR is the provisioned rate of the port. So if you're selling a customer a 50 meg circuit, you might provision the port for 55 to allow for bursting or whatnot. And so if you want to test to see if you can get to that 55 or what it looks like, then you can set that. A lot of my customers actually turn that off. They don't want to share the EIR information with their customers. So we'll go ahead and turn that off, and we'll leave it on CIR. If you're doing any burst testing like CBS, EBS, it's disabled right now because we have burst testing disabled within the EtherSAM setup. So in a different window, I can activate that, And when I do, it makes this available. So we do support CBS and EBS burst testing. Down here in the bottom right is a performance criteria. I almost always leave this unchecked. Unless I know exactly what the SLA requirements are for these particular key performance indicators, I leave it off. Because if you were to turn this on and you don't have these values set appropriately, when the report is generated, it will do pass-fail based on these criteria. And so you might get some false indicators because these are not set up right. So usually I'll just turn these off because I just prefer the absolute number. And then up here on the top left, we can set up our profile. So right now we have it set, the frame set for data. We can go into a profile and we can select different options. And so if I wanted to do, say, voice over IP G.711, I can simulate that by selecting this option here. Now, of course, it's not actually creating a voice over IP call. It's just matching the frame size and whatnot for this particular codec. So if I were to close this out and look at it, you would see that G.711 uses a fixed frame size of 138 bytes. So I'm going to go ahead and set this back to where it was at, which was data. And I had this at 12.5 megs. So I'll go ahead and set that back where it's at. And then set this back to 64. So let me return that. And so down here at the very bottom here, test parameters, if you need to test for policing or rate limiting, this is where you can do it. And so basically what this allows you to do is it checks to see if your rate limit and your policing is activated. So it'll test up to a certain rate. So it'll test up to your CIR or EIR, and then it'll go beyond that to see if it's able to test. So it'll do pass-fail based on that. I'm going to go ahead and leave that on in this particular case here. And so I have set up a single service, 64 bytes, using 12.5 megs of bandwidth. And so down here at the bottom left, I will now go over to the MAC IP UDP tab for this particular service. And each one of these 8 services sets up separately. So the initial setup does take some time, but once you're done, and I'll show you at the end, we're able to save the configuration to streamline this process the next time we test. So here in the MAC IP UDP tab, you kind of see how we've laid this out. This is basically laid out like an Ethernet frame. Up here in the top left, you see couple with interface. If I were to check this, the source IP, the source MAC, some of the VLAN information will couple with the interface setting. So in the original screen, or the original setup we did for the interface, these options in here would be coupled to this particular service. And so I'm going to go back over there, and I'll just uncheck it, because in this case, it doesn't really matter for us. And so here under MAC address, we have our source and destination MAC address. And so you can see it's the same here because it's just looped back onto itself. But if you were testing to a MAC swapping device, or if you were testing to another test set, particularly one that wasn't EXFO, that is doing MAC swapping for you, you would put the destination MAC address for that device right in here. In this case here, we're resolving off of an IP right now. But if you were testing to a MAC swapping device, this is critically important, this is where you would put that destination MAC address. Now we'll go over to the IP tab next to it. So if you are in an IP-aware environment, so say routers and whatnot, this is where you can put your destination IP address. So this is the source IP address of this particular test set, and then here's the destination IP address, which happens to be the same one. If we were testing to, say, a transparent loop, this is probably something we would do. And of course, we resolve our own MAC address, right? On the far end, if you remember, our looping device, we gave it a MAC address with a .2 at the end. So I'm going to go ahead and hit a .2 here, and then you'll see if we check and uncheck here, that way I can show you it resolving. It's resolved that IP address here. So if I go back to the MAC tab, you'll see that we have a different MAC destination MAC address now. This is actually that far end device that's set up right now. So again, if you're testing to some sort of a IP aware system or address based aware system, this is one way you can set it up, is destination MAC addresses, destination IP addresses. And so that's what we have set here. So let's go ahead and click on this last tab here. It's the global tab. Once you have all 8 of the services set up, and in this case I do because I did that earlier, you can actually get in here and quickly review how those are all set up. So we see the source and destination IP addresses here. If we go to SLAs, we can see what sort of test we're running and what frame sizes. So you see there's that 2,000 byte jumble frame that I put in there for service number 8. The cool thing is that you can actually get in here and edit them as well, edit some of the basic information. So if you see this first one here is not enabled yet, so that's why we're not seeing the full 100 megs committed yet. So if I were to get into the addressing here, just click on that, we're able to edit this. So I can get in here and change this back to, say, 146 again, and hit OK. And now if I were to close this here, you'll see that now it's set for 146. And if I go in and enable it, we are occupying 100 megs of the committed bandwidth. I'm going to go ahead and close this up. And then we can work our way to this very last window, which is the EtherSAM window here. So let me go ahead and expand this window. And this is for the test configuration. If you are testing to another exfo device, like another exfo Ethernet test platform, you would select dual test set here and discover remote. And if that device has the appropriate link and network information, then you would be able to find it, scan the subnet, connect to the device, loop it, do head-to-head testing, whatever you need to do. So in this case here, I do have an exfo test set on the far end, but I'm using it as a smart loopback device because I want to show you how to configure for those types of elements in play. So we'll go ahead and leave it unchecked. Here for the sub-test, so how EtherSAM works is it does a configuration test. So this one right now is set to ramp, so it'll go in at 25 seconds for each service and then ramp up to kind of do a pre-check to make sure that all the configuration is set and that you're able to actually test. In fact, if I were to go to the ramp tab here, we can see how it's going to test. So for each service, it's going to go there 50% of CIR, 75, 90, then it'll hit CIR, then it'll go and check for rate limiting on top of that. So this is how it's set right now. If we had it set for burst testing, in fact, if I were to enable this burst testing here, this would allow you to edit the CBS, EBS information that was in the other screen. We can get in here and see how the burst is set up. So you can customize this, the way it ramps and the way it bursts as well. So in this case here, we're just going to do a quick ramp test. And then after it's done with the configuration test, it'll go in and do a performance test. And so this is the actual burn-in where it'll test all 8 services at once and then measure the key performance indicators. So right now we have it set for 10 minutes. I'll probably drop this down to, say, a minute or so. So I think the minimum measurement is 1 minute and the maximum is 30 days. And we've actually done a 30-day test before, so that's pretty amazing how long you can run these. So in this case here, we'll just run it a minute. And so the test duration is about 1.5 minutes. We're not accounting for the transition time between the services, so I bet you this is going to be probably closer to 2 minutes to 2.5 minutes. And so once we have this set, we can go ahead and minimize this. And if everything is set up right, we should be able to just start a test. And so we'll go ahead and do that and see what happens. So over in the top right, I'll hit start. And then so we'll transition over to the test setup screen here, or the summary screen rather. And so we'll see the service configuration test is running, and then we get aborted, timeout during execution. So something has happened. So the thing with tests that are service level agreement tests like RFC 2544 or EtherSAM is if you don't get frames back, it's not going to run a test. It's just going to abort. We don't want to generate a report because we have useless information here, so we need to figure out what happened. So I'm going to go back to the setup, and I know exactly what happened. What happened is our destination MAC and IP address was wrong. So if I were to go in here to the services tab and look at the first service, we'll see that the destination IP is .146. And so, of course, the far end device is .2. If you're in an address-aware network, the only way that your test frame knows how to get to the far end is if you give it an address. It could be, or some path to get there, whether a VLAN ID, an IP address, a MAC address. It has to have some sort of address identifier to tell it how to get to the destination. So in this case, we don't have that set. Okay, so what I need to do is I need to change the destination IP addresses of all 8 of my services to 10.10.10.2. So I'm going to go ahead from this global tab, and just to remind you of where I'm at, if I go back over here to Profile, this is where we set up the individual services. So you can be on any one of these services, just select Global, and then from here we can hit the addressing button up here, and this will allow us to do something very cool, which is batching. So I want to change the destination IP address to .2. So I'm going to hit the batch button here. I'm going to go to destination IP, and we're going to set this one for 10.2. And we're going to apply it to all 8 of these services. So, in fact, I can leave this checked as well. We're going to batch the source IP as well, or I can turn that off. It doesn't matter. I mean, this is already correct. So if I wanted to, I could turn that off. But you can kind of get an idea of what we're doing here. So we're basically batching. So I'm going to batch all 8 of these services to use this IP address. So we'll go ahead and apply that and let it do its magic. So this saves really a ton of time. If we close it here, we will see that we are now set to 10.10.10.2. So we should be resolved to the IP or the MAC address of the far end device. So if you look here at the destination MAC, you'll see a different MAC address here. So this is my MAC swapping device on the far end. So if I close this now, we can verify just quickly in this global tab what it looks like to make sure I got all 8 of these correctly. And then I can minimize this, and now I should be able to perform a test. So I'm going to go ahead and hit start and let it run its test. And so here's the service configuration test that we talked about, and we're already starting to get information back. So now it's going to run through at 25 seconds apiece and do all 8 services to verify that it can do the actual test itself. And then once that's done, it'll do a service performance test for about 1 minute, then it'll save the results. And so if I were to go into the service configuration tab here, we can look at the different services to see what they're doing. And so you'll see how it's ramping up slowly to CIR, and then eventually to check for policing on that particular service. And again, this is going to take 25 seconds apiece, so I'll probably speed it up here so we can get to the end, and then we'll continue from there. All right, thanks to the magic of video editing, we've fast-forwarded it to the end of the service configuration test, and you'll see how it's done all of the 8 frame sizes and slowly ramped up and then measure the performance. And so once we are done with this last service, so this jumbo 2000 byte that I have here, it's going to switch over from the service configuration test over to the service performance test. And remember, that test is going to run about a minute. And so now you see how it switches over? In fact, I can go to the service performance tab here to get a quick summary of it. And so this is the beautiful thing about EtherSAM Y.1564 is it's measuring all 8 services at the same time and giving us all the key performance indicators, unlike RFC 2544, which only gives you a snapshot sequentially of the 4 different tests that it runs. And so this will run about a minute, and we're seeing that on each one of these services we're getting our 12.5 megs. So if you add this all up, this is our 100 meg line rate for this particular test. If I go over to the service performance tab here, we can look at the individual services, and this is why I like to name them. It just gives me a better idea. So you can name this whatever you like. You can name it small bursty traffic, whatever. So in this case here, I named it 64, so we can see if there's any sort of out of sequence, any sort of frame loss on this particular service, and then we can scroll across and look at all 8 of them if we'd like. And click on it and go back to number 1 here. And so once we've gone through our minute, the test will stop, and then it'll ask us to generate a report. And so that's where we're at right now. So I'm going to go ahead and hit yes. And so this is where you will populate as much information as you can in here to make the report more professional, I like to put in as much information as possible. So here's just some stuff I had in here from before. I'm going to generate a PDF. So you can do HTML as well, but PDF is probably the most preferred that we see. And it's going to save to the internal flash, which is what I like to do. And it's going to generate the report after it's done saving. So I'm going to go ahead and save it. And I'm going to overwrite whatever I had there before. And so now it'll generate a report. So it's going to export over to PDF, and then it's going to display that to us, and then we can review it real quick. And so this is what the report looks like here. It looks very professional. All the information that we have in there, the configurations, the 8 services, all the key performance indicators, the whole ball of wax. And so everything's also very conveniently hyperlink capable, so you can go directly to that section if you'd like. So I'm going to go and close that out since we have our report. Now, if you wanted to manually generate a report, you would just hit the report button here, and it would open up that same window. So we're not going to save it again, obviously. Everything that we've done up to this point, the 8 services, the IP addresses, the MAC addresses, all of that, we could save that configuration. So I've already saved this one once, but I'm going to go ahead and hit the Save Load button there. And then this is where we could save this configuration. So I can name it whatever I'd like, So we could say this is a demo config. And then hit OK. Give it any sort of summary we'd like or information. Add it to our favorites if we'd like, and hit OK. And it'll save this configuration. So the next time I want to test an EtherSAM circuit or do SLA testing with Y.1564, I would basically go to Save Load and then load that configuration, the demo config. And then the only thing I would have to do is change any sort of addressing information. Destination IP address, MAC addresses, and all of that. And of course, if you go back over here to Setup, we would simply do that, in this case, in the Services tab. I'd go in here and batch change everything to whatever I needed. And then start a test, and then you're off and running. And so basically this is Y.1564 testing with the Exfo FTB1 with the 880 module. And again, if you have any of the 800 series Exfo Ethernet testers, any of the 88100 series, the interface will be the same. If you have one of the older ones, a lot of the information that we cover in here, it may look different on some of the older interface, but the information is very relevant. Knowing the IP addresses and what VLANs are, and those types of things are going to be critically important for setting up those tests as well.